And so now, I mean, sometime later on, I'm going to get into like show you the example of how we can find the data, how we can find the correlation coefficient. But for now, we're just briefly talking about it. So you can always, rewind that video tape where you found that formula to copy down the formula somewhere onto your page and study that formula. And then later on, I'm going to show you the example. Now, that is about the correlations. The meaning of the correlation here is that the whole point of a lot of times we're trying to plot. Now, remember the age variable, right? The age data values here were, what we had was a so give me 1 second here. So the age that we found, that we collect, was pretending to be 17, 18, 17, 19, and 20. Okay? And then the pop quiz score, okay? The corresponding pop quiz score is like a 15, a 20 here, and a 17, and a 19, okay? And a 25. So now the idea now is that one of the important idea about, normally what we would also want to do with the two data set here is that we want to put them on a graph as data points. So the idea is that you draw for yourself a graph. This time it's not like the bar graph that we have done before. It's not like the histogram that we have done before. It's not like the stem plot that we have done before. We are talking about, now, remember, you can call this one right here x, and you can call the pop quiz the y value. And so on your graph right here, this direction here is the x, that axis right here is the y. And so what I see is that 17 for x, we got 15 for y. So I would like to say about, this is 5, 10, 15, and this is 20, right? And then this is 25 right here. And then we got 5, 10, 15, and 20 right here. So when we try to plot these points right here on the graph, what I can see is that when your age is being 17, your pop quiz score, so this side right here, right, is for pop quiz. Okay, and this side right here is for age. Okay, so when your age is being 17, which is about almost halfway between 15 and 20, okay, so that's where 17 is, right? And then your your pop quiz score will be about like 15. So this is your first point right here. Everybody with me here? All right. So now that's your first point. And then moving on next, when you are at 18, when your age is about 18, which is right there, right? Then your pop quiz score is a perfect 20. It's a 20. So you can see that it's right there as your point. Okay? And then once again, furthermore, if you're looking at 17 again, another 17, but this time you have exactly 17. So you're going to have another point right up here, which is exactly 17. So that's another point of yours right there. Okay, so these are, once again, this is the way how we plot the two data values, the two data sets together. Each pair right here, we plot them as a point on the graph. And then when you have 19, you would have 19 is about here. You would have also 19, so you have another point right there. Okay? And then when you're reaching 20, right? Your age is 20, then your pop quiz score is about 25. So right there. So now, if you look at all these points together, it seems like, they kind of like all everywhere, but then they do kind of form like a trend that is kind of going up, right? If you look at all of that together, they do kind of seem to go up, right? So my point is, the point now is that we're trying to expect when the correlation coefficient that we are about to compute later on, the meaning of that correlation here is it's going to be a way to help you find out if these two data here on the graph, if the two data sets here on the graph is going to behave like all going up or like going down like this, or it's like all scattered around. Okay, so that's the whole point right here. That's the whole meaning of finding the R right here. So as a quick note for you to remember, okay, as a quick note for you to remember, then when your R here, okay, the closer R is to positive 1, right? Then the more going up to the right, the more going up to the right, your relation or the relation is. Or it's like more positive correlation. Positive correlation. Okay? And then the closer R is to the negative 1 value, right? The more going down, to the right. Okay? Your relationship. Is. Okay? So this time here is going to be more negative. Okay? And then last thing here is when the R, if R is closer, if R is closer to 0, right, then no conclusion can be made. No conclusions can be made about the relationship between the two data sets. Okay, so that's the basic idea so far that we're gonna look in taking account into our problems later on. And then also, before we start, and then the idea now is, as I have demonstrated earlier, I mean, a lot of time your data, we can plot them just like these scatter points, right, on the graph. And then, like say this one right here, the way I'm drawing that, you can kind of see that they're going up, right? They can form like some kind of like a band that is going up. And so the idea now is that a lot of time we're trying to draw like a best fit line. I mean, the line does not necessarily have to contain all the points here, but then at least the line here is some kind of like a line that is closest to all these points, the line closest possible to all these points here. That's why we're calling that the best fit line. Okay? The best fit line. And then so this line right here, in a formal term, we call that the linear regression. The linear regressions. Right? The linear regression line. And so, of course, it's a line. So at this point here, I do expect that you have some algebra background right here. A line always has the equation. In order for you to plot, to draw that line right here, you need to know the equation of a line. Then the equation of a line is always y equals mx plus b. Okay? This is something that you should be able to recall from your algebra class. All right? So now, the idea now is that the equation of the line, the m here, which is the slope, right? The slope of the line, which is m, is to be determined by the formula. Now, your correlation coefficient here times with the fractions s sub y over s of x. Now, these s of y and s of x right here, they are your standard deviation for the data x and the data y. Okay, so that's how you can find the m. Now the b right here in your formula, the b in your equation can be found by the actually, we don't really need to worry about the b in our class here. I'm sorry about this, but normally we only really care about, you know, the slope of that line is what we really want there. Okay, so this is all the idea that we're going to be looking at in the further problems. Okay, so let's go ahead and start looking at some example of how we can get the correlation coefficients, and then from there we can go ahead and find the linear regressions. Okay, the slope of the linear regressions.